In Colorado and around the US, there are coal mines that leak large amounts of methane because, for geology reasons, when you dig down into gassy geology, that gas comes out. There's no way to plug it good enough to keep the gas underground, and we're going to present a couple of case studies on climate action. We mentioned those organizations already. So, Tara, do you want to do this part, or I can keep going? All right, so methane, as you guys know, is 80-something times worse as a greenhouse gas than CO2, and capture can be monetized via greenhouse gas offsets. What you're looking at here is ice on our local irrigation reservoir, and this is bubbles of methane coming up that have disturbed that ice and kept that hole open all winter. And then over here, that's just natural spring breakup. But that's natural because the creek cut through the gassy geology, but if you rip a huge hole in the mountain, that gas is going to come out faster. That's what you're looking at here is methane, and well, you're seeing water vapor coming out of an abandoned coal mine. Also, that coal seam is on fire, so not great, but many gassy mines in the country, and if we capture that methane, that's immediate climate impact because it's a super warmer, and then that's also improving air quality. Many of these places are located in rural areas that are experiencing job loss, so we can take some of that workforce and point it towards these efforts. We got 2 locations here in Colorado. One is in Pitkin County and one is in Delta County, and they have very different economics. Coal Basin is the one in Pitkin County. It is public lands, public minerals, challenging to get to, and we're setting some precedent at the federal level, which is not moving right now. The Bowie number 1 mine has easier access. It's private land and minerals, and we have set some precedent at the state level. Did anyone from Colorado Energy Office come in here? No, I tried to recruit them. It's fine. And so our overall goals are to mitigate climate change by reducing methane emissions, and specifically we need to design and permit methane capture in Coal Basin, and then we have demonstrated that we can do this over at Bowie number 1.
I walked in front of the projector just like I was told not to. I will orient you all to Coal Basin. So like Chris mentioned, this is in Pitkin County. This is about 100 miles west of here in Breckridge, for anyone who's not super familiar with Colorado, just south of I-70 and outside of the small town of Redstone, Colorado. It is located on White River National Forest public land, adjacent to private land, and like Chris mentioned, challenging to access. It's about a 4-mile hike in from the parking area up to the main mine portal. And my basic understanding of geology and mining is that essentially these coal seams and the rock formations that surround them are overlaid on Huntsman's Ridge in one direction, and the mining, when it was in operation, happened in this direction and this direction. So in order to access those coal seams, the miners drilled down in and across into the mountain to break up and access the coal. And what happens when those rock formations are disturbed is that the gas that exists naturally throughout and amongst the methane leaks out, both through the boreholes and mine shafts and the main portal that you see over here. This is the header of the portal that they could actually drive trucks into. And that gas that exists naturally then leaks out at a much greater rate and volume. It also leaks diffusely through the soil. So we see methane coming out from a lot of different parts of the mine. And in the lead up to our field season in 2023, we reviewed a lot of this historical information, both the EPA and the Colorado Energy Office in monitoring and reporting on what this mine has done in the period of reclamation since it was closed in 1990. They have reported that there's a significant amount of methane likely leaking up there. I think some of the initial reports that we were working with estimated that there was 9,000 tons of methane leaking annually. So we used that historical information and information from the mine operators to develop our approach to our field season in 2023. And we knew that we were going to take a top-down and a bottom-up approach to measuring methane throughout the complex. And it was a great time. There were donkeys carrying solar panels, there were drones, there were broken bones, there were lightning storms, and it was a great time. Took us about 5 months over the course of the summer. The top-down approach was mainly aircraft-based, so we flew 7 flights around to help identify overall how much methane we were working with and where on the ground we should target for some more refined measurements. And we believe, this is maybe anecdotal, but that this is the best studied abandoned mine complex, at least in the country as far as we're aware of. So this is a picture of one of the aircraft data sets that we got. Basically, they flew the plane in a big circle around the 10 square mile area of the mine and measured the methane coming in and the methane coming out based on the prevailing wind direction to give a very general estimate of methane that could be attributed to the mine complex. And the average from the 4 flights that we performed was around 2,000 metric tons of methane. So compared to the earlier Colorado Energy Office and EPA estimates of 9,000 metric tons, we're working with something a little bit lower. Still a significant amount of methane, and to us, worth exploring further. This is another one of the flight patterns that helped refine our on-the-ground work. So this is called a raster flight and helped us basically pinpoint some locations where methane was likely to be coming out. So we did see methane where we expected to. We knew that main event portal where you saw the mine header there is a big leak source. We were able to measure that with just handheld methane detectors. And we were able to see that in this flight pattern and map. We also identified methane in areas that we weren't yet aware of, so that kind of shaped our on-the-ground approach, which, we ended up collecting data from more than 20 sites. So this is where the donkeys and the drones and everything came in. We spent a lot of time hiking around with semi-permanent methane detection systems. We'd leave them behind for several weeks at a time to collect and measure how much methane is coming out over the course of that time. There's variance depending on time of day and atmospheric pressure, and Chris will get into that a little bit more at the Bowie mine site and how that mine, which is a little easier to access and we have more data for, we kind of use that to model and project based on the data series that we collected at Coal Basin, what that might look like over the course of the year. So we expected that the sum of what we were able to find on the ground was going to be less than those aircraft measurements, simply because we knew we're not going to be able to find all of the methane that was leaking on the ground. But we were able to confidently identify where somewhere between 200 and 400 metric tons of methane per year were leaking out at the Dutch Creek 1 mine site. So that is, again, that portal that we've talked about. And we also know that Dutch Creek number 2, which is adjacent and sort of uphill from there were several sites there where we were able to identify and quantify significant leak sites and use that information to kind of inform what our mitigation plan is ultimately going to be. And I'll pause there because that was kind of the summary of a year worth of work in collecting this data and analyzing it. Great fun. Highly recommend if you have mine infrastructure in your communities, exploring this as an idea. And one of the things that was really important for us throughout this process was to be open and transparent with the communities. There are pros and cons to taking this sort of climate action. We'll talk about in the coming slides what our actual proposal is and what the impacts are, but we wanted to be upfront from the beginning with the community and get their perspective on things. It shaped our approach to actually measuring, the measuring portion of this. We thought about opening the road to begin with. There is an abandoned mining road there, but determined ultimately that we would hike in for this portion to reduce the impact until we were really sure that it was something that we wanted to pursue. And yeah, that's kind of where we want to go eventually in with this group, is getting any feedback from you all on community engagement efforts that you might have held in your community around controversial topics like renewable energy installations and things, because this proposal is not without controversy. So this is an image of what the system that we're proposing to install looks like. It has a footprint about the size of a shipping container. It has a lifespan of 20-ish years, and it's called a regenerative thermal oxidizer. It's basically a giant catalytic converter that takes the gas stream and the methane and burns that gas stream and converts it into CO2 and water. So like we mentioned, methane is 86 times as potent as CO2 as a greenhouse gas. So although this still results in emissions, it's nowhere near as potent as releasing all of that methane into the atmosphere. The impact of what we're proposing is approximately a 10-acre space that shipping container would need to sit on a concrete pad. The road would need to be reopened. It's about 3 miles long. We would need to be able to get the shipping container and truck traffic up there to install the system. So that's kind of a big piece of the impact. And then just cost-wise, estimate $4 million capital expenses plus around $250,000 of operating costs annually, but that this system has the potential to destroy between 200 and 400 tons of methane per year, potentially more. To put that into some context, depending on how you do the math, this is around, overall, the leak up there represents around 25% of emissions in Pitkin County, and what we're proposing to mitigate is about a quarter of that. So 6-7% of emissions in Pitkin County are what we're proposing to mitigate for a few $1 million and some truck traffic and ultimately some other impacts to the area. But compared to some of Corps' work on buildings and the dollar per metric ton of carbon impact, this is a very significant opportunity in terms of greenhouse gases to make a huge impact in our backyard. Chris will talk more about this and how it's going at the Bowie mine, but I mentioned that when you burn methane with the RTO, it creates CO2 and water. The water as a byproduct can be used for reclamation of the mine site, and that's something that we've committed to in our proposal to the Forest Service, is putting up a bond to reclaim the site, and some ideas about how we might use this water towards low priority residential wells in the Crystal River Valley. So current status of this project, we did finalize our application for a permit from the Forest Service back in April. They've been a little busy since then, and now they're on vacation. And we're still waiting to hear ultimately what's going to happen there. But we did receive a grant this year from the Colorado Energy Office for just over $700,000 that would go towards the installation of a mitigation system. We've had great support from Pitkin County. Our study portion of this project was funded by congressionally designated dollars from Senators Bennett and Hickenlooper, and we continue to be in touch with their offices about where this project is headed and where we hope to go with it. So that is kind of the current status of things, and I just want another opportunity to point out the donkey with the solar panels, because that's my favorite photo. Some specific challenges related to Coal Basin are, again, the fact that this is on federal land. You can, and Chris will talk about what it's like to purchase an abandoned coal mine that's on private land, and logistically maybe a little bit easier. But it is precedent setting. It's something that exists in other mountain towns, which is why we wanted to bring this project here. And we think that there's opportunity for similar projects to happen in other communities. Some specifics about this site, because it's a 4-mile hike in. there's not electricity at the site at the moment. We looked at what it would take to run electricity up there just by a power line. That would result in more impact. So ultimately have proposed powering the system with solar and a backup diesel generator. Overall, the net emissions reduction is still significant enough so that the emissions of what it would take to power the system and basically turn it on when it goes off are insignificant compared to the amount of methane that we can actually burn. So yeah, and again, there's trade-offs between climate action and other impacts. When we're talking about opening the road, that means increased truck traffic and what people would consider development, and it's a temporary effort to install the system, and then it would basically operate with pretty little input and need for visitation up there and such. But there's other ecological, wildlife, hydrologic considerations, but again, that's something that we've committed to best practices and mitigating to the extent that we can through the process of getting our permit with the Forest Service. So that's the basic rundown of things at Coal Basin, and I'll hand this back to Chris now to talk about what that looks like in practice in an actual mine.
Thank you, Tara. This is the view from the Bowie number 1 mine. Town of Paonia is down there in the valley. And this is the view of the mine site itself. So there used to be a bunch of infrastructure here, including conveyor belts coming downhill, but it's been largely reclaimed. The Colorado Energy Office estimated about 1,000 tons per year were leaking out. Again, in our study, we came up lower than this, but that would cause $1.7 million in social cost. Raise your hand if you know what a social cost of pollutant is. All right, that is actually the best ratio of any audience I've had, so that makes sense. But basically, methane causes ozone, which causes respiratory disease, which has economic impacts, and we have really smart economists that have figured out how much per ton. And so this site is costing us as a society a lot of money. What we see happening is methane coming up from the mine void, and this is the old portal. When they reclaimed the portal, they plugged it with earth and then they buried it, and we see that gas coming up right adjacent to the road. And what we did is we put a big tarp here, which you can see there. We put a big tarp over that leaky area, and we put a pipe underneath the tarp. It's very analogous to a radon mitigation system, if you know those. And then we put a pipe down the hill, and we burn it in this big stainless steel tube. We put a fence around that after we took that picture. We can shoot flames out the end when the mine is really exhaling. In addition to the tarp, we drilled into the mine in 4 different places, and we pumped expansive foam into the void. It's the same like great stuff that you get from Home Depot in the shake can and use to seal up around a door or something, except we put about 20,000 pounds of it underground. And the methane is now coming out this other borehole that's more in-by is what we call that. So the methane comes out there, and that's a more efficient capture system. I told you we drilled 4 holes. That's not totally true. We drilled 5 because we missed the mine once. That was an $18,000 mistake. I think we were about 6 feet off. And anyway, so sealant, methane capture, that was just a camera observation hole. A couple of good photos. There's the rig going in. You see the tarp. And here's our downhole camera. This is Sam, the drilling guy. He was excellent. He would get out of his truck in the morning, take off his cowboy hat, put on his hard hat. That's who you want doing this. Sealing, we had a crew come out to seal, so you see the white and black barrels, that's like part A, part B for the foam mixture. Then they were pumping that underground, and it has to be warm enough. Of course, we were doing it like over Christmas, and it's just the coldest day of the year. And so we had this truck. The heater in the truck wasn't working well enough, so we went and rented another heater, and we're just like pumping heat in there trying to make that happen. It was It was a glorious time. So on the far side there, you see the part A and part B going down hole, and then here's just what it looked like at night. Once it was actually working, they're like, no, we're not stopping until it's done. So they went past midnight that night. Water manufacturing. So I'm a chemist by background. When you burn any hydrocarbon, you make CO2 and water, and you're also making heat. There's enough gas that we can get meaningful amounts of water, not meaningful on an agricultural scale, but meaningful on a household or even local ecosystem scale, several hundred gallons per day. So we did this in Somerset and demonstrated that, and we're now doing it up at Bowie, where you saw this. We're going way back, way back. Here it is. So we just extended this way out. It's several hundred feet long now, and that's long enough for the exhaust to cool down until the water condenses. Nope. Coming back. All right. So what did it actually take? It took about $1.4 million total. We got a bunch of grants. We purchased the land. If you go to purchase an abandoned coal mine, your lawyers will tell you not to. But we clarified, is there any way we can lose more than the money we're putting in? And they said, no, not if you color inside the lines. So we went ahead and did that. But we spent about $30,000 evaluating the site and our liabilities associated with that. The Colorado Energy Office gave us some grants. We got some grants from the federal government. And then we have a line of credit because that's helpful. So with specific challenges, we needed to get that money, so risk-tolerant capital. The drilling permits and the air permits took a long time to get. And so we had to hassle the state about that. And then there's wildlife considerations. So that site is great winter range for deer and elk. And there is a golden eagle nest complex pretty close to the methane leak. So this is an adult golden eagle and a baby golden eagle and a rabbit providing nutrition. But the fact that we could just purchase this made it a lot easier. Here is the adult golden eagle came down to investigate our biologist and said, leave my nest alone. He was a safe distance. This is all with a big telephoto. This is the eagle when it was getting ready to fledge, so kind of awkward teenage dinosaur. But this one successfully left the nest, and the next summer it came back from wherever it went to help its parents hunt and raise the new chick. I showed this to one of my friends who had a new baby, and she said, I wish I had a teenager helping out with the groceries and cooking. And I said, well, wait 14 years and have another one. So what did we get for that? So we got about 2 jobs. We talked about just transition at the start of this. That mine probably employed 250 people when it was operating, and we got about 2 jobs out of it. It's been pretty fun. We've destroyed quite a bit more than 150 metric tons of methane since then, and that's great. That's similar to taking 7,500 cars off the road or, transforming them magically into Teslas and getting some solar to charge it, which might cost over $300 million. So from a climate action standpoint, this is really low-hanging fruit, and it's really impactful. Which is a thing I just said. It's a big deal. We've been able to get public and private support. If anyone has a high energy application and they want to come get some heat, we got plenty of heat. You saw that horizontal stainless steel pipe earlier. When that thing's probably right now it's glowing red hot, and you can see it at night, and it's interesting. There we go. That's it. So we'll leave the conclusions up and take any questions.
Yeah, question.
So when the methane satellite went up and went down, were you able to compare any of the data that it might have had for this site with what you got?
We had asked the methane satellite to look at our site, and they were like, no. So I don't know. I don't think we were not talking to the right person or didn't have the right connection. But if you have the right connection. Oh, yeah. Yeah. And they don't work as well in hilly country as they do in flatlands, is my understanding.
One other important thing to note. So we talked about this had been studied previously by the EPA and the Colorado Energy Office. They knew there was a lot of methane leaking up there. It's not a economically viable scenario to produce electricity or anything like that from the methane at Coal Basin because it's not concentrated enough. So no one has ever been interested in coal. I mean, there's been interest, but there's been no incentive to go after it. So for us, from a climate perspective, it's really about the dollar per metric ton of carbon impact and what that looks like compared to some of our other work. But for others, there's less incentive. At Coal Basin, $250,000 annually is probably a high estimate, but basically, I think once it's up and running, probably monthly maintenance, and so we've proposed being able to access the site during the winter, probably by snowmobile because it's several miles, and then during the summer, if there's any needed maintenance, trying to concentrate that during the good weather season, and so averaging out to something like once a month up there, but there's probably also an engineer and maintenance crew needed on hand to be able to do that work. Then there's some energy costs associated with running the equipment throughout the year. We gotta manage the project internally to be able to sell offsets and monetize those. And anything else I'm missing, Chris?
Yeah, to the extent that we are selling offsets, it costs about $20,000 to get them verified and sold. And then we have an IT guy who runs the computer systems and makes sure that we can operate remotely. I can, from my phone, change the valve position on our flare and do more or less gas depending on how much the mine is exhaling. And that's not because I'm a tech wizard, it's because we got a guy named Don, but he's kind of expensive. So our operating costs are looking like about $80,000 a year at the Bowie No. 1 site. That is the theory. That is how we were able to raise private money. Yeah. So for the Bowie No. 1, that is private, and we think we will be able to sell enough offsets to have that be profitable, and then go do it in other locations. For Coal Basin, that is something that's a great benefit for society, but probably doesn't pencil out unless we find an offset buyer that just absolutely loves the project and wants to pay a premium for the offsets, which do exist out there, but that's why CORE is involved, because it makes sense that way. So we'll probably have to fundraise to keep the project running. Yeah.
You mentioned cost per
Sealing former oil and gas wells is fantastic climate work. Depending on how leaky they are, it can be more or less cost effective. We've sealed some wells in Illinois that cost $3,000 to seal, and I just got a bid to seal a well in Pennsylvania for $60,000, and it's all over the place, both in the quantity of methane and in the cost to plug. But it's in the ballpark. It's all worth doing. Does that answer your question? The vent pipe is horizontal to do the water manufacturing. So what you saw was 60 feet of pipe, but then we've run that out another 100-some feet, and that's enough to cool down and get water out. A normal methane destruction device is a vertical pipe, and in fact, that's what those were before we modified them. There is a lot of heat coming off that system. We do vegetation management all around to mitigate wildfire risk. But when it's really windy, I'll just turn the system off because I worry about a tumbleweed hopping the fence, catching on fire, hopping the fence again and going. But we've had the local fire department up there while it was running, and they were like, cool. If there's a fire higher up on the mountain, are you good with us using your road? I was like, all right, I thought you'd be more nervous about this, but.
So the system at Coal Basin that we're proposing, the regenerative thermal oxidizer, is a little bit different than the system that's that is at the Bowie mine. Chris, do you want to elaborate on that?
Yeah, a chemistry thing is you need a certain fuel-air mixture for things to burn. If you got too much fuel, you need to add air for it to burn. If you got too much air, the heat gets diluted and the reaction doesn't continue. So in Coal Basin, we have too much air, a lot of fuel, but it's dilute. So that's why we need the regenerative thermal oxidizer to keep that reaction going. At Bowie, it's plenty rich gas. We add some air, we add a spark, and it goes. Does that answer your question?
My question was more about just how the regenerative thermal oxidizer is enclosed as far as wildfire risk in national forest.
Yes. It is enclosed in a big insulated box, and the exhaust from that is under 200 degrees, and so the risk from a fire would be more like a squirrel chews on a wire or something like that than the actual reaction going on.
Okay, I have multiple questions.
Go ahead.
I'll ask them all, and if somebody else wants to interrupt me, you can.
I think we got plenty of time.
The permitting. So I think while the federal permitting process is onerous on the national forest land, I understand that it might be a little less. There may be fewer steps than what you had to go through at Bowie with the different agencies based on land and minerals and whatnot. But we did initially get a permit. We were issued categorical exclusion for our study portion to collect the data, and that was basically because of the fact that we were just hiking in and did some plane flights and some drone work, but not a lot of impact just based on the study portion. What we are proposing right now to actually install the system will require an environmental assessment, so not an environmental impact statement, but middle of the road there, and that's mainly what we have to deal with at the federal level. The BLM is interested in being kept up to date on what we're doing. Their understanding is that they don't have jurisdiction over the mineral rights. However, they want to be kept in the loop in case there's something that they're missing. So that's kind of the gist of things at Coal Basin. Am I missing anything?
Yeah, at Coal Basin, we will also need state permits from the Energy and Carbon Management Commission, which that's the oil and gas and drilling people. We did propose a small borehole there to do some sealing and methane capture, and we had to get that at Bowie. That was the first such permit that they had ever issued, and I had to lightly harass them to get them to actually respond and make that happen. We also had to get an air quality permit from Department of Public Health and Environment, and that was fine and straightforward, except they're understaffed, so it was really slow. With the tarp, we put in the tarp because the drilling permit was so slow. So I told people that the tarp was going in, but it was I was not asking permission, and no one said no, and it went in, and it's fine. Tell me your other questions. I don't remember for Pitkin County, but they did give us a grant, so that's something. At Delta County, we traded some emails, and then I went ahead.
Okay.
Yeah.
The second question was about community pushback, community reception, and then the third part was about how do you operationalize the heat and the water.
Yeah.
About the community engagement. So again, this was a really important part of the process for us, was being open and transparent and hearing from the community what their priorities were.
And we would love advice from you all.
Yes. I think that, again, this has some translates to things like installations of renewables and pushback from the community around things like that and other climate action. Specifically, the local community, it's a very small town up there. They do not want to see the truck traffic and are concerned about that, extending out into the future. From our perspective, it's a few months period, acknowledging that, things go wrong and these processes can get extended, but it is a temporary period of construction, basically, to reopen the road and bring in this system and install it. And then after that's when we're aiming for that once a month sort of maintenance visits, and even less frequently when possible. Like Chris said, these systems can operate remotely and operate on their own for the most part. So that's one major consideration, and again, why we didn't propose opening the road just for the study portion of this. Some of the other factors are the road itself and the erosive nature of the basin. It's an old coal mine. There's a lot of shale and erosive sediment in the area, and so we know, and the Forest Service knows, that opening a road there comes with some other considerations and design considerations and what it means to, maintain that road. Again, something that we're committed to designing and committed to best practices around, but recognize that it's a concern as far as water quality and sedimentation and such. But again, because we are going through this whole federal permitting process that would involve hydrologic evaluation, as well as ecological, wildlife, archaeological considerations, those are all things that are factored into the review process. And then the other interesting piece is the private land that's adjacent to the forest there. There is a bike park that operates on that land, and they would like to expand that bike park. And we think that this project is compatible with expansion of the bike park. The current park goes through, old holding ponds from the mine, and what we're proposing is a road that has been reclaimed, but still currently looks like a road, just with grass over it. And so in our opinion, it's not incompatible with expanding the bike park or continuing the operations there, but can understand why, you don't want to be mountain biking around truck traffic. But again, think that the overall greenhouse gas reduction potential for us outweighs those other priorities, and we are committed financially and in our proposal and philosophically as an organization to mitigating those to the greatest extent possible while still realizing those emissions reductions. So we've held 12, 15, I don't know how many community events. We had an advisory group that met monthly of local stakeholders, including government and organizations that work in the valley. So have put a lot into the community aspect of it.
We did a couple of hikes with community members, and we read somewhere that you should try to get people who work different types of jobs. So maybe one day you do an evening session and the next day you do a morning session. And we did get some, like the people that were just interested, we got good new people. But then the opposition, there's like Chuck and his two friends, and they came to both ones to say the same things. So we like Chuck. We listened to him. Heat and water. If you have clay and heat, you can make ceramics, and that's why my company's called Delta Brick. We made bricks for a while and realized it wasn't economic, and now we make tile, and that is currently running off of grid energy, but we have a gas kiln up at the Bowie mine that we will hook up soon. I've had so many presentations where I say, like, we're going to hook it up soon, or like it's going to happen. but soon. It is going to happen, and I'm looking forward to that. So we make really nice tile. The water, we're not making very much water right now. It just goes on the ground and makes some plants happy. We need to extend our system a little bit more to get further cooling effect. And then the main thing that we're going to do is put that in a tank, like a stock tank, and have that be available for deer and elk. And we'll have to like look at the salinity and that sort of thing. But they love that site because it's a grassy, south-facing, sunny slope. But to get water, they have to cross the highway and get to the river. So if we give them a little water source there, that'll be positive. And then any additional water that, when that tank is overflowing, we're just going to have a sprinkler putting that out on the landscape to improve the forage and let the plants grow more. There was a question there. Yeah, I don't know about Idaho specifically, so I doubt that there's gassy coal mines in Idaho. It is for weird geology reasons. So ours are because volcanism came up a few million years ago and punched through this coal that was 65 million years old and just vaporized a bunch of the coal when that magma came up. There's gassy mines in Utah, there's gassy mines in Appalachia, in Illinois, and in like Alabama. Yeah, usually gold and silver mines are not gassy. They have their own problems with acid mine runoff and so forth. Trona mines are sometimes quite gassy for reasons I don't understand. The carbon credits, we abide by the American Carbon Registry protocol, and what they require is that, one, you demonstrate that it was leaking anyway and that you're not just sucking gas out of the ground that would have stayed underground. And then two, you measure every 15 minutes, you batch a measurement. We measure flow rate, methane concentration, and flame temperature constantly. And then we batch those every 15 minutes and report that to the verifiers. And basically, that's what it takes. Does that answer your question? In the front.
You described the mine as exhaling. What causes the fluctuation?
Yeah. So the mine is a big void underground with some bottlenecks to the surface. And gas in the rock is under very high pressure, and it flows to the mine void, which is relatively lower pressure. But because of all the gaps and cracks to the surface, the mine void is really just slightly above atmospheric pressure. And as that atmospheric pressure swings, there's kind of a daily cycle up and down, and then you'll also see more like weekly systems as storms come through. We'll get inhales and exhales because when the mine pressure is lower than atmospheric pressure, you get an exhale. Atmospheric pressure comes up, forces air into the mine, keeps the methane down. Does that answer your question? Yeah.
How many years will the mine leak for, and over that period of time, does it decrease?
Yeah. So when the mine is operating, they typically have a huge amount of gas, and then when they shut down the first few years, it drops a lot, but then it gets asymptotic and just is a very slow decline. So we probably see between 5 and 10% decline in methane per year, but then it just goes on forever. Wow. Oh, Tara, did you want to say something?
There are plenty of ways of doing carbon capture. I think that the feasibility of what that looks like, particularly in this area, we're not there. So this is a system that is achievable for us, has a big impact on overall emissions, is ultimately maybe not the ideal solution, but in the terrain that we're dealing with, in the climate that we're dealing with, the amount that we're dealing with, I think carbon capture and storage and things like that are kind of a whole different ballgame and yeah, something else to figure out.
Is there any way to
get the CO2. That's
not create CO2 to begin with. No.
yes. So you can do, with these projects, you can do anything from an engineering perspective and does it make sense from a money perspective. So we've talked to guys that want to make hydrogen and they're like, hey, we have a whiz-bang catalyst. It's going to make solid carbon and it's going to strip the hydrogen off of the methane and then you'll get some hydrogen and you won't be releasing CO2 and you can sell that carbon or something. So that's certainly possible. Probably cost another couple $1,000,000 to do. You can capture the CO2 coming out, probably cost a couple $1,000,000. So there's other gassy coal mines in this valley, like right next door. And so I used to have a slide that was a little like decision flow chart, and it said, do you have $2 million? If yes, like go mitigate a coal mine. And then once you're out of methane to mitigate, you start looking at the CO2. Yeah. So the mine breathes in and out, and a bunch of atmosphere gets in the mine. The oxygen tends to react with the geology. We mostly see nitrogen. I will check live and tell you the concentration of methane right now. Wait.
The percentage of methane is over 90%, though. The concentration is low. Something like. Go ahead.
So at the Bowie mine, we're currently 24% methane, and the rest is mostly nitrogen. We see some CO2, we see a little bit of oxygen, and then we see higher hydrocarbons, ethane, propane, butane as well. In Coal Basin, at that one big leak, that mine has a lower entrance that sucks in air, almost like a chimney effect. And so that methane is typically between 1% and 2% by volume. And that's why it won't hold a flame and you need the regenerative thermal oxidizer. The northern Colorado mines do not have a ton of gas. The ones that are on the surface, like the Bridger mine, ? Surface mines, you can't get the gas because it's coming out the surface. Really big tarp, maybe. No is the short answer.
It's one of the reasons why we're here is potentially to identify and also encourage you all to think about in your own communities if there are opportunities and know that we are here with information and several years of experience to model what this looks like and could look like in your communities. I don't think anyone knows the answer to that. I mean, in one way that we're looking at it, you know, they want to make some of these permit processes at the federal level less arduous and take less time. And so we're kind of like, okay, maybe we'll just get pushed through because they want to permit economic activity on federal lands and they won't notice that we're doing it for the purpose of climate. Maybe. I mean, I think that there's a range of outcomes that are possible that, again, comes back to the value of the outcome for us to remain committed to the process and see it through both just from our perspective as a nonprofit, a climate action nonprofit. You know, we've got a quantitative goal of reducing 150,000 metric tons of carbon over the next 6 years from the projects that we support. We also support our local communities, Pitkin County, Aspen, Basalt, Snowmass, et cetera, the entire area in their climate action goals. And this is in unincorporated Pitkin County and would go a long ways towards helping them achieve their climate action goals if we're able to install this system. Yeah, in the back. That is an adjacent area of methane mitigation that at least I'm curious about. CORE doesn't work on landfill methane or solid waste, but the county and the city are both interested, and so we're looking at, are there overlaps? I think the technology is a little bit different and maybe just the application of it, but yeah, it's another opportunity. There's a lot of methane that leaks from the landfills. There are other systems that do this. These kind of systems operate on active, oil and gas operations. As far as the technology, regenerative thermal oxidizers, Chris does a lot of this work, and he's referenced different locations where that happens. We have been part of a couple groups of methane scientists and the approach to this at the global level. So try to keep tabs on that. I don't know. Do you have any other specific examples?
If you heard the talk from the Venezuelan guy today, this is another example where we're behind. Uruguay. Thanks. The U.S. is behind in this area. China's really good at methane capture. They drive buses with like big balloons of coal mine methane on them. Germany, Australia have a lot of capture systems. Yeah.
Yeah, we actually, as part of, we didn't talk about this, but as part of our proposal at Coal Basin, we have proposed another sort of experimental bioremediation system at a different leak site. So it's leaking a little bit less, it's a little more diffuse, and we're proposing basically bioremediation in big drums of like bacteria that eat methane. I think that at this point for Coal Basin, the proposal is out there, but again, we're open to other applications of it and future research and yeah.
And what we proposed was in those drums was just a high surface area medium for the bacteria to live on. And that very well could be biochar. I would love an introduction to the CSU guy because that'd be useful. Yeah. We are just about at time, but we'll hang out a little bit if anyone wants to chat more. Thank you all so much.